the feature, like the enhance the area, yes, in contact with the surrounding environment, and then we can enhance the effect, increase the heat transfer. For fixation or better adhesion, so it depends on the specific application. Okay. Wow. Sorry. Tailor materials by varying alloy composition for microstructure, for functional grading, and thermal post-processing. Yeah. So this is actually not designed for additive manufacturing, but tailor material. Yeah. Faster design, print on demand, functional prototyping, and so on. Yeah, it's not important for here. Okay. So you could see that on the right side, there may be a difference between the CAD motor and the direct metal laser sintered parts. Yes. So the surface roughness is high comparing to the motor because this is the limitation of the technologies. But you can overcome these issues by adding, so let's say 2 mm additional materials, seen as the stop allowance, and afterward we can performing the post machining process like milling, to eliminate materials and enhance surface qualities of the part. That's just one option. Yes, you design for additive manufacturing is mean that you design not only for the structures of the component, but you design the structure you design the materials. You select material for fabricating part as well, and therefore you design also the printing parameters and so on. But here for material, we uh, select material rather than, yeah, really design. So there is a possibility of using spooled wire. Spooled là cái cuộn dây đúng không? Cuộn dây. As electrode in gas meter arc welding or filler into molten pool as in plasma arc welding and direct energy deposition. Right. Generally speaking, the chemical composition of wire is already optimized because it's developed for a certain period of time. And to accommodate with the cooling rate and loss of alloying element when transferring across the arc, because you know that the arc, cái hồ quang đúng không ạ, cái hồ quang này nó có nhiệt lượng rất là cao, mà khi mà cái vật liệu chúng ta nó đi qua cái vùng hồ quang đấy thì cái nhiệt lượng cao đấy nó sẽ nhìn chung thì nó sẽ làm nóng chảy kim loại. Tuy nhiên sẽ có những cái kim loại của các nguyên tố hợp kim đúng không ạ, nó có nhiệt độ nóng chảy thấp thì những cái đó nó sẽ bị bốc hơi mất, thì nó sẽ có khả năng bị mất cái alloying elements bởi vì cái sự bốc hơi vaporization. Accommodate strength reduction in the heat affected region. Wire spool and wire feeder small enough to be positioned in a gun. So like yes, in a gun. So we yeah. Both the heat source equipment and the wire can be equipped in the gun. You keep equipped in the gun. So SB part base plate. So above we have the figure describe the gas meter arc welding. Below is the plasma arc welding. And during the welding process, you see below you could see that you have the heat source, you have the material deposits by layer onto the previous layer of the part, and surrounding we have the shearing gas, shearing gas, act as an inert environment to prevent the multimeter from the oxidation reactions. Therefore, we need the shielding. Yes, gas. The wet consumable vendor provide information on material property, chemical composition, blah blah blah. Yes, it's not important. Certain high-strength alloy might require specific component preheat, yeah, plus in the past temperatures for heat treatment. Yes, so this is some kind of treatment for the materials. Yeah. But here we did just a comment. Yeah, a comment which summarize based on the textbook. And here we do not speak about, we do not talk about a specific example here. Because for high certain strength alloy, we don't know which type of alloy we are talking about. Yeah. But there exists this situation where we need to require the specific component preheat and interpass temperatures plus heat treatment. Yes, for hydrogen releasing. In terms of the powder bed fusion for meter AM, the powders are generally optimized to be used for sure. It should be small enough. It should have they should have regular shape. Yes, yes, uh, and this is necessary to avoid any kind of agglomeration in order to assure or guarantee the flow, the bulk density. Yes, this can be done by controlling the purities, by maintaining the spherical powder or the powder with regular shapes. With the control size, it means the diameter range. Yes. So in doing this, we can somehow assure or ensure or guarantee the flow and bulk density of the materials. And common AM powder, as I remember, we have talked in the second chapter. Yes, we have steam powders. Stainless steel powder, I can say, is 316 ounce stainless steel. You can have also 17 for precipitation hardening steel. Titanium, we have the titanium aluminum 64 powders, several incognate nickel based superalloys. We have different types of aluminum alloys in the form of powders for metal AM. So, for example, aluminum, silicon, tin, magnesium, yeah, and others. There are many types. Okay. And generally speaking, the powder size, when fabricated, and they are has the size range in between 20 and 35 microns for laser powder bed fusion, larger for the direct energy deposition, which are range from 35 and 100 microns. Yes. And in terms of the powder bed fusion using electron as a heat source, and then the powder input should be largest, starting from 80 up to 100 micron in terms of the diameters of the powders. Price different differ significantly and can range from 100 US dollar per kilogram to 1,000 $1,000 per kilogram, depending on the alloys and specification. Yeah. So I would highly recommend that you use certified AM powders. Yeah. To avoid any kind of risk to the additive manufacturing process. Đừng có dùng vật liệu trôi nổi, đúng không ạ? Nên dùng những cái vật liệu mà đã được certified, đã được chứng nhận để giảm thiểu những cái rủi ro cho cái quá trình tổng hợp bằng cái phương pháp additive manufacturing. With current AM metal powder process, we should use recycled powders, uh, but it lost its pedigree. Pedigree dịch một cách nôm na là tính phả hệ. Ờ, because why? Uh, one of the method in order to control the properties of the output part is to control the input materials. So if the part has any problem, and then you could trace back what is the reason resulting in the kind of damage or defect. But if you mix, you use the recycled powders. Generally speaking, you mix the new powder, one third, 30% of new powder, 30% of reused powder, and around, let's say, for example, 40% of recycled powders, and then yeah, you lost the pedigree. Yeah, for prototyping, because you don't know actually afterward uh, which powder is used for making the part, because you already mixed them together. The gas used in the additive manufacturing provide the pressure vessel with various purities. Yeah, which mean the quality of the gas. Mm, yes, and in terms of the purity of the gas, is control the amount of oxygen and other elements. So the amount of oxygen should be maximum 2 part per million, and the other should be restricted at maximum 10 part per million. Yes, for the high purity grade. Depending on the material which is in form of wire or powders, and the AM process, the nitrogen generator may be integrated to supply the processed gas. Yes, and please keep in mind that the process should not be done at temperatures above 3000. Otherwise, the nitrogen molecule will be, uh, how can I say, will separate and to create the nitrogen atom, which is quite reactive. But in the normal conditions, nitrogen can be considered as inert gas. Yeah, for sure. Only at very high temperatures, and nitrogen can react with several metals. So just be careful about using nitrogen as supplies processed gas. That is processed gas. The partial vacuum chamber may be required for high level of atmospheric purities and to be used instead of introducing the inert gas. And despite of the risk of loss pedigree for the used material, the use of recycled and reused material offer the, the sustainability feature or sustainable features for the AM processing. Yeah. Wow. So here we have a chart, or yeah, it's not actually a diagram, but it's a figure showing you the relation between the powder properties, the bulk powder behavior in process performance, and part properties. So the input powder's properties will have a big influence on the properties of the final part after the additive manufacturing process for sure. For example, the morphology or the powder side density the powder side distribution will have a strong influence on the density, because if the morphology or the shape of the powder are regular, so it's easy to pack them together. Yes, easy to pack them together, and easy to enhance the density during uh, the materials in design process. But if you have the irregular powders, the shape is not very keraton, and then it's quite difficult to pack. And then inside, you can expect that a lot of porosity, and we do not have 100% relative density. Yeah, just lower density than comparing to the case of using the powder with regular morphologies. Uh, yes, and the powder side distribution. So in general, people prefer to use the bimodal distribution rather than a single modal distribution. And what is the bimodal powder side distribution? And you could check from the internet, because it's actually is two bell curve, and they combine together, and we call the bimodal powder side distribution. The impurity for sure increase the amount of impurity inside the input material. We have an increment of the risk of the defect after the fabrication of the part by additive manufacturing, and so on and so on. The moisture đúng không ạ? Intrinsic density, particle density, and if the particle already contain some kind of voids inside, and after the additive manufacturing process, this void may be kept, yeah, there, and as a result, it will reduce the density of the material. So the particle density is also important, and this, yeah, can affect the accuracy, the dimension accuracy, for example, of the part. Yeah. Let me check. Mhm. Material composition. No. Composite. Mhm. So we can talk a little bit regarding the composite material. Generally speaking, for additive manufacturing, we prefer employing the metal matrix composite, or the composite material, which is composed of the metal matrix. Yes, and the second phase, which is considered as a reinforcement rather than fiber reinforced composite, rather than fiber. In other words, I till now I do not observe the case that people use the normal additive manufacturing process in order to fabricate the fiber reinforced composite. Yeah, it's possible, but I rarely observe, I would say. Seldomly observe or rarely observe. So, yes, for composite material, to create this material by using the current additive manufacturing technologies is challenging. So, since we use the layer by layer approach in AM to fabricate the part, so if the uh, the reinforcement, the fiber reinforcement align along the Z direction. So will be for sure there will be discontinuity in Z direction if the reinforcement is aligned along the Z direction. So it's not reasonable. And therefore, we should pay attention to the in-plane reinforcement where the reinforced fibers is or are arranged on the plane of the layer. Yeah, on the plane of the layer. And most and for the additive manufacturing composites, we observe uh, more frequently the particle reinforced composite. So the second hard phase in the form of the particle well dispersed inside the metal matrix, and that's why we call metal matrix composite. Yes. For example, the glass fillet nylon powders. Yes. For sintering process. Note that the properties of AM material depends on process parameters, pre-orientation, geometrical design, material feedstock properties. Oh, I would like to say that not the properties material of AM material does not only no, do not only depend on these parameters, but depend on more than 180 parameters, not only these parameters. But these parameters are considered as the most important factors that need to be carefully considered prior to the additive manufacturing process. We need to appropriately select these parameters, the orientation, the geometric design so that it's suitable or is appropriate with the certain additive manufacturing technologies and the material, feedstock material, whether this is in the form of powders or wire. You need to be compatible with the technology that you have selected for the process. And now there are two tables showing you the application of the most common additive manufacturing methods. I'm sorry, common is not the most common. Some is collected by the John Maleski and the other by Li Yang. And the two reference, the main reference for writing, for preparing the lectures, and you could, if you are interested in, you could find and read, but it takes quite a long time, to do that. Yeah. But you are encouraged to do so. Alloy type, yeah. Within the alloy type, we have aluminum, marking steel, edging steel. So it's mark tensile plus edging steel, stainless steel, titanium, cobalt, chromium. Yes, nickel-based superalloys and precious metals. So I do not know about the precious metal. Yes. Nobody knows everything. Cobalt chrome I have heard, but I do not work with. Yeah, there I know. For aerospace, we use aluminum because it has low density for sure. Stainless steel possibly to be used for making the landing gears. Titanium for those who work under 600 degrees C. Nickel-based superalloys for turbine blade that can work up to 800 degrees C or more. If you need more, if you need to work at higher temperatures and you need to apply the thermal barrier coating uh, to cover the external surface of the nickel-based superalloys part. For medical, generally speaking, people use the stainless steel, yeah, to create some kind of fixations. Uh, if some a patient has problem with their bone and needs some kind of fixations, yes. If their legs are broken and you need some kind of support, and this can and the doctor can use telestin and print out in order to support, because the doctor can customize the features of each patient. Some will be some are tall and the other is they are not very tall, and in that case, yeah, they need to modify uh, the part or the support accordingly, and individually modify individually. Titanium, yes. Titanium, we know that is biocompatible and it can be used to to fabricate the implant parts, like the dental implant, yeah, the insert into the jaw, yeah, the jaw, yeah, yeah, and others, yeah, and others, many. Automotive can use the aluminum alloys for the additive manufacturing process. Stainless steel titanium, yes, and the other like nickel by super alloy is quite expensive and it's not suitable for making the automotive parts. Corrosion resistant temperatures, high temperatures, yeah, we cannot forget the name of titanium alloys and nickel by super alloys, yeah, and so on. And on the right side you observe another tables summarizing several specific material for particle fusion in AM. So for example, titanium aluminum 64 along with the modulus of elasticity, ultimate tensile strength, percentage of elongation, and these can be fabricated by several AM system. So it's quite famous to recognize here is the EOS system with the headquarters in Munich, SLM System Solutions with the headquarters in Lübeck, both are in Germany. With the commercial poor titanium, we, there's no information regarding the modulus of elasticity. 360 nails stainless steel, margin steel. Yeah, I have mentioned about their 17.4 precipitation hardening stainless steel because it's quite, yeah, it's quite great in terms of the strength, in terms of corrosion resistance, moderate high temperature working condition. I mean that it can withstand, it can retain the strength at moderate temperatures. Chromium alloy, nickel based super alloy Inconel 625 and Inconel 718, and another type of aluminum for alloys for the additive manufacturing, which is quite famous, is aluminum silicon 10 magnesium. Yeah, and I think it's enough for today. Yeah, a lot of information. And please remember that today is the 6th day and we have the total 8 days. And please prepare your assignment as soon as possible. Yeah, and keep a certain period of time for any modification if necessary. And don't forget the deadline. Don't forget that two students inside group uh, they must refer to one paper. And once the name of the paper is defined, and I don't care if you work alone or if you work in group, but you are encouraged to work in group. But no problem, it will not affect the result, uh, whether you work alone or in group. And as usual, I will be here until 3:35 to answer any of your questions that can be arise. And at the same time, I will check your attendance to give for you to earn the 10% of the final mark. Yeah, regarding the attendance. And thank you for your attention. And I wish that you have a nice day ahead.